Good morning to both of them. My name is Simone Agostinelli, and I'm going to show my tool demonstration called SmartRPA, a tool to reactively synthesize software robots from user interface logs. Before going on to the demonstration, it's important to understand the main research field of our work, which is robotic process automation, namely RPA. With the RPA, I refer to a set of technologies that allows to replicate the routine tasks in place of human users by means of software robots. One of the major issues of the current RPA tools is that they are driven by predefined rules and manual configurations made by expert users and not by automated intelligent techniques in order to define the behavior of software robots. Indeed, this practice is time-consuming and error-prone. In this direction, we developed a cross-platform software tool called SmartRPA with the aims to automatically develop the software robots directly from the user interface logs that record the user's observed behavior without the manual intervention of human users. Indeed, we envision a three-step approach that allows us to train the RPA routines based on the user interface logs, to abstract the events to an high level, to skipping the manual modeling of the flowchart diagrams that describe the behavior of software robots, and third, to implement and enact the software robot emulating the most suitable routine variant, also in presence of decision point. Here, with the decision point, I mean a point in the execution of the routine that needs a user intervention to enact multiple variants of the same routine. So here we can see the conceptual architecture of SmartRPA, which integrates 5 main software components. The first one is the action logger that is able to record the user actions coming from the system application, Microsoft Office events, and also the browser ones. All these user actions, so all these events are logged into a CSV event log by a login server. Then the next step of our architecture is a log processing that allows to merge different CSV event logs into one data frame containing n traces where n is the number of training session. The third step is the event abstraction component that allows us to filter out the relevant events, group similar user actions into one, and describe them in an informative way. The fourth step is the process discovery that, starting from the high-level event log, is able to generate the high-level workflow. And the last component is the generation of the RPA scripts, both in a Python format and for UiPath Studio, a commercial RPA tool. So let's start with the tool demonstration. In this video, we can see the graphical user interface of SmartRPA that allows us to select on which applications record the user actions. In this case, in this running example, we select the clipboard, the Excel modules, and the Google Chrome ones. As we can see on the background, the login server is starting. After that, we can open the travel authorization request, which is an Excel file. We can open under the Google Chrome web browser the Google form, and we would like to emulate the copy and paste user actions between the Excel file to the Google form. So here I'm starting to copy and paste the elements, but here, for the sake of time, we skip the rest of editable fields, and we click on agree, yes, and reject. It is worth to notice that in this case we click on reject, but in the next training session we will click on accept in order to identify a decision point. So here I stop the logger, I close the Excel file, and we are ready for another try for the second training session. So here now I click on the start logger. Everything is up and running, and we repeat the the same procedure as before, but with other payload values. Indeed, here after I will open the Google form, I will start to copy and paste other values. So in this case, I will pass an aggrego, then I will pass a full professor and the corresponding email. So even in this case, I will skip all the editable field for the sake of time, and this time I am clicking on accept rather than reject. So this concludes the log recording phase. Here we can see all the user actions that are stored in CSV event log by the login server, and then we can move on the next phase of the architecture. In this case, I will import in SmartRPA the CSV event log built as before, and everything will continue in the pipeline process. In this case, we can see the high-level workflow that is generated by SmartRPA, in which each activity represents an event, so a user action, and here a multiple click can be merged into one single radio button, because from the point of view of the RPA analyst, is good to have only the user action associated to the click button. Here we can see the discovery of decision point between the car reject and the car accept. In this case, we select car accept, and here the process model describing the routing traces that we selected is generated. With this dialog, instead, we are editing all those events that can be added. For example, the text field on the Google form. So after we click OK, the software robot, according to the decision we made and with the values we edited, will be generated. In particular, we generate a Python software robot that emulates the user observed behavior, as we can see. So everything is automated, and we generate also the software robot for the UiPath Studio, which is a commercial RPA tool. As you can see here, we can run the software robot, and the behavior is the same as the one that we defined with the Python software robot. So the steps are identical, and everything is correct. So this concludes my tool demonstration, and thank you for the attention. If you have any question, I'm here to answer you.
Thank you for the presentation, Simone, and thank you for having started before I arrive.
Yes, because
you did well. No, you did very well. Huh? It was the right attitude. Thank you very much.
Okay. You're welcome.
So, are there any questions? Please, because I lost the beginning, so I would not have too many questions, but I was preparing myself to tell to all demo authors to have more time, 7 minutes instead of 5 minutes, because there are not too many questions, unfortunately, in the morning. So, questions, please. Okay, so I will ask the classical question. What was the intuition and the problem statement which led you to make this research and to provide this demonstration, this prototype?
Okay, so I come back to my the problem statement, which is the answer to your question. The major issue that guided me to develop SmartRPA is that in a robotic process automation, the current generation of the tools does not allow to automatically develop the software robots, but they need the manual intervention of human users that have to manually model the flowchart diagrams, and with the SmartRPA, since everything is recorded, and with the process discovery, we can skip the flowchart modeling. So the principle is that we can skip all the manual the initial manual labor with the SmartRPA. This guided me to develop SmartRPA. So this is the main research question that I addressed in this demo.
Okay, and in which kind of processes did you experiment that?
In reality, I experimented the SmartRPA with the case study that is happening in our department. That is the travel authorization request for going into mission, and I extracted a subset of user action as a running example for this demo. But in reality, I don't test my tool on synthetic processes or real case study. Only a case study that is happening in our department.
Okay, but it's an interesting case study because we know that it is a time-consuming and very repetitive process. So, in how many instances of processes did you have the chance to apply this prototype?
Okay, 50 instances. We applied this with the prototype in 50 instances of the same process, which is the biggest one that I show in the demo. Okay,
and did you observe the improvements in the executions in terms of time and quality?
Yes, because once you I observed advances because once you the most difficult thing is in the recording phase, but once the recording phase is done, the improvement will be later on the execution of the software robots. So yes, there is improvement in our case study, but I cannot answer for other case studies.
Of course. Okay, thank you. Are there questions for Simone? Okay, otherwise we will leave the room to Radiana.
Okay.
See you soon, Simone.
Hi, so I'm sharing.
Hi.
Can you see my screen? Yeah.
Yes.
Okay. So, hi everyone. I am Radiana Koce, and today I'm going to present the demo paper, Pattern Lens, Inferring Evolutive Patterns from Web API Usage Logs, done together with Xavi Franch, Petar Jovanovic, and Alberto Abeo. So before going to the online demonstration, I would actually prefer to start with 2 or 3 slides just to give a bit of context and the main motivation behind our work. So even though Web API evolution has gained a lot of attention, one of the main problems of this process is related to the provider decision on how, when, and what to evolve in their Web APIs. So 2 of the main driving forces of Web API evolution are requirements from the companies that are exposing the data or services via these Web APIs. And secondly, the behavior of the consumer that access every day several endpoints of the Web APIs. In our work, we will focus on the second one, on the analyzing consumers' behavior, so that the providers can take it into account when planning the new releases of their Web API. Actually, consumers may report bugs or even request new endpoints using several communication channels built by Web API providers. But this kind of feedback may be partial and biased based on the specific endpoint these consumers may use. And also, it is difficult to gather and interpret at a scale. For this reason, we focus on the Web API usage logs that are logs generated while consumers access the Web API. These logs contain all the interaction between consumers and the web API. They contain all the endpoints the consumers have accessed. In each order, they have called these endpoints, the frequency, and also with which parameters they are calling these endpoints. So to address the problem of understanding consumers' behavior, we introduce PatternLens, a tool that supports providers in planning the changes and analyzing consumers' behavior recorded in the web API usage logs. So this is the big picture of the interaction between consumers and web API. And here is where our tool stands, PatternLens. So the main input of our tool is the file, the usage log file generated while consumers access the web API. We assume that this file is preprocessed, which means that not only the irrelevant data are removed, but also the information this log file contains is structured, which means that every log entry should have one timestamp, should belong to one session or one case, and also should have a proper endpoint that the consumers are calling. So these three requirements may recall you of process mining, because these three are the three requirements an event log should have to be used as input for process mining input. And actually, the first part of our tool, the metrics calculator, uses process mining concepts to extract from the logs several metrics regarding the endpoints, like the frequency of the endpoint, the frequency of the sequence of endpoints, and so on. And then the second part of the tool, the patterns detector, uses as input this set of metrics and also a set of predefined patterns, and then detect and display to the user, to the web API provider, the different patterns that the tools find in the logs, and also the change that this pattern may imply. So now to show how the tool works. So this is the main the first interface of the tool, which is quite simple and intuitive. What we ask from the user, from the API provider, is to upload the usage the API usage file. In this case, I'm using API usage file from a district health information system, which is a web-based health management information system used by several NGOs and institutions, and even by several departments of WHO. And as I said, this file should have the timestamp for each log entry, should have a case identifier, and also the endpoint that the user is calling. So after uploading the file, what we ask the user is to enter the number of times, the minimum number of times that a pattern should appear in the log file, so that the tools display it to the consumers. Let's say the user choose to be displayed the patterns that have at least appears at least 200 times in the file, and then submit this information. Then the user may ask the tool to display all the patterns. So these are all the patterns that the tool was able to detect in the log file. Along to each of the pattern, we add several metrics that are relevant to the pattern and also to the source and the target node. For example, the confidence is the relative frequency of the pattern regarding the source and the target node. The source node is the first called endpoint in these two node sequences, and the target node is the second called endpoint. The type of the pattern, the affected consumer, so the number of applications where this pattern appears, and also if consumers, when the user, web API providers, click on one of these patterns, extra metrics display to them, so that they can better decide if this pattern is relevant to them or not. Here, the user, API providers, have the possibility to accept or reject the pattern. Actually, this tool is designed for web API providers to be used. So we assume that the user has a strong prior knowledge in the web API that the tool is going to analyze. So this kind of knowledge is actually required in this case. So the API providers may decide to accept one of the pattern, and the tool in this case will display all the applications that are affected by the change that this pattern imply. In this case, as the pattern implied to create a new endpoint that combines the source and the target node. If the provider decides to implement this change, so to combine these two endpoints in one unique endpoint, then this application will be affected by this change. The user also can decide to reject because he thinks that the pattern is not relevant to him. Currently, this tool is able to store all the information about the metrics of the pattern that the user is accepting or rejecting. And we plan to use this information not only to improve the tool itself, but also to improve the way we detect several patterns. So more or less, this is the main functionality of the tool.
Thank you, Rediana. So are there other questions from the audience? We are a small audience, you can see each other.
If I may?
Yes.
Okay, so thank you for the presentation. I'm sorry to Simone, I didn't catch the beginning, so I couldn't have good questions for him. I think this is interesting, the idea of looking to actual usage of the API to find out patterns. Once you do find them, what in concrete would be the actions that you would suggest to the makers of these web APIs? If you could give a concrete example.
Yeah, for example, the action depends on the type of the pattern. So in this case, this pattern tells that consumers, before calling the endpoint API program rules, they frequently call API program indicators. So as these two endpoints are frequently called next to each other, so what we suggest is to create a new endpoint that combines both the target and the source endpoint. So in order, instead of calling two different endpoints, the consumers can call just one endpoint. So this way,
okay.
The improvement would be to reduce the number of calls.
So these patterns that you are capturing have typically two endpoints only, or is this adjustable to sequences of longer sequences of endpoints?
This pattern may have two or one endpoint, but not more than two. For example, for one endpoint are the self loops. So in this case, this is the type 4 pattern. So we see that the source and the target node in this case is the same, because this pattern implies that this pattern tells that after calling this endpoint, the user the consumer calls again this endpoint. So this is the self loop, and in this case, it has just one node. So the patterns want one or two nodes, not more.
But is this a limitation or something more that you would see in the future to maybe to expand to more longer sequences?
More than a limitation is a decision, because as the changes that we will suggest will be like to merge these two endpoints or to create new endpoints regarding these two. Maybe it's too ambitious to think that we can merge 4 endpoints for different endpoints. So we start by only 2 patterns with 2 endpoints, and then this process may be iterative. So after, let's say, introducing this new endpoint by merging the source and the target node, we see that the consumers are calling this new endpoint and another one, so we can merge them too as well. So it's iterative.
Okay, makes sense. Thank you.
Thank you.
Thank you. So are there other questions? Otherwise, we can move to the next presentation. Thank you, Rediana.
Thank you.
Yes, sure. I guess I'm the next one. Let's share my screen. So yeah, welcome everybody to the presentation of my demo paper with the title Designing a Self-Service Analytics System for Supply-Based Optimization. So this means we are now in the area of purchasing and in the position of an buyer who has to optimize their their supply base to be at the end more effectively and more efficiently the whole organization. So, but the motivation and the main challenge in supply chain management comes, basically to understand this, you should look at the historical context of supply chain management, and also especially regarding supply base reduction. So the supply base is, contains basically all the suppliers and organizations an organization have to cover their demands. And around 70 years ago or something like that, it was that you really maintain large supply bases to intensify the competition between suppliers, to really lower your prices and to buy goods at the lowest price possible. But things slightly changed, and nowadays you really want to reduce your tremendous large supply base. So, for example, this research initiative was also conducted with the Robert Bosch GmbH, and it is like that there are over 50,000 suppliers in the supply base which need to be somehow maintained. And you can imagine how many people or employees do you need to manage such a big supply base. And also through this competition decade, there comes also this new approach of really cooperating with suppliers and doing more in partnership approach rather than being really against each other and lower competition. And therefore you need much more resources to manage your suppliers in the supply base, and therefore you have to reduce and shrink down your supply base somehow. And at that point, as we set it up, this research project, we have this idea that there are definitely preferred suppliers we really wanted to keep in our supply base. But on the other side, there are very much small suppliers, which small meaning having not much volume and really also not covering very much demand, but they are still making up the supply base. And they are typically flagged in supplier relationship management systems as not preferred, or please do not order something by those suppliers anymore. But it's really a question, can you just block this supplier, so reduce it, or do you lose then demands because those demands cannot be covered by your preferred suppliers? And usually, as I want to draw here also usage scenario to make it more tangible for you, is that we have at the Robert Bosch GmbH, and I'm pretty sure also at other purchasing departments in large organizations, buyers on different hierarchy levels, which I found out usually have the role more as a business analyst. So of course they are buyers, but they usually have to analyze really large amounts of data, doing this with Excel every time, which was funny to watch at, because today there are much more powerful tools in there. And what if we can provide those buyers a powerful tool, also leveraging and machine learning algorithm or several machine learning models to really help them shrinking down their supply base without losing any demands. And the usage scenario is always the same, I guess. So there is this bundling team manager. So purchasing is organized in bundling teams, just for your notice. And the bundling team manager usually says it falls from the sky to say, so this year we want to reduce 30% or 20% of our suppliers, and maybe look at the tail end first, because there are many small suppliers we can reduce probably. And but the corporate business analyst then asks himself, oh, how can we achieve this? So, and then we have this tool set it up. I will show you quickly in a few minutes. And let's look into this tool, and our data scientist has built for us, and look where we have the highest potential for a reduction. And so where are the material fields? So purchasing is organized in material fields. So in which material field and in which region can we really reduce our suppliers without losing any demand? And the tool offers this possibility to really spot on this regions and say that we have there on high potential. And you can really dive also then deeper into it and judge this based on the items which are purchased by these suppliers. But the corporate business analyst does not have is not a real expert in a sense of that he or she is not really knowing what is really needed by the plants. But therefore, we have this regional business analysts who can really judge this. And therefore, the corporate business analyst has now identified an regional business analyst, because from the tool, he knows now in which region and which material field we have a very high reduction potential, and then he can follow up with her and say, yeah, can we shift these demands? I saw them in the tool. Can you check this, please? Here in this bubble, and then she's asking and investigating this on item level and really can clarify this with the tool, and also can then follow up with the suppliers to let them cover more demands, so the preferred ones as before. And to just give you a demo of the tool, so keep in mind we have this bias on different hierarchy levels. And first of all, I play now the role of Tom. Let's say Tom, the corporate business analyst, and yeah, just switch windows here. So I've already opened this app here. So this is the tailored analytics showcased by the paper also. And it's like that Tom and buyer at the corporate level, I just said, has to select his bundling team, and we currently only have MRO data in it. So this is maintenance, repair, and operation. And so this is another view. So this is the view he will get initially, and then he sees here in this material field, for example. So because he is responsible for this material field 1, he can investigate now the supply base. And sees now here, there's much data behind it, anonymized data, of course, but a lot of, he sees now here where we have potential for reduction. So for example, here the non-whitelist suppliers, so the ones which are flagged for reduction, are here displayed red. And we can define here this threshold and define here with this threshold, if we, I don't know, this volume threshold, we can also say that. So usually you define your threshold very low because these are the smallest suppliers and you want to use them first. So this was maybe too low in this area. It's loading. Or maybe I also have to just run it once again here. So here I selected now this material field 2, and now can also define, so for which volume to look at first, so the very small ones, and also how certain the distribution, the reallocation should be in sense of the algorithm parameter. And he said that, oh, for this material field, I know that we are kind of very it's okay if we are not very certain that these items can be really shifted, because for example there are only colors in it for wall painting, for example. And now he can investigate even further, as I said here, and he see now that for example at material field 22 we have a very high reduction potential, and then he can click on this here and sees now on a supplier level, so for which supplier volume can be shifted here. And here are also some other criteria here in it, and also for which region. So we have selected here also a region, and it's here on this x-axis. So region B1 and B2. So imagine this is maybe, for example, Asian or Northern Pacific or whatever. So, and then he can select here one supplier to see which items are here. And here's only, let's see the items here. You can click on the rows here and see this purchasing item here, yeah, can be shifted with a probability of 25%, for example. But there are for sure also items where the rest category, so where based on this probability threshold, where the rest category is not 0%, and where we have items which can definitely not be shifted to a preferred supplier. And therefore, but here in this material field, it seems to be that, let's select another one where we have maybe a rest category. Yeah, here. So for example, this isn't supplier we can possibly reduce, but still 75% of the items are remaining. And you see here that 25% of the items, so these are 2 items, can be shifted to this supplier with this number. And there are much more other items where we have a low probability, which can be maybe shifted to this supplier, but only with a probability of around 50%, you see here. But so this is now the work the regional buyer would do, she can now follow up also with this supplier to maybe ask if really this item cannot be delivered. So if we select maybe another one, just to play around with the tool a bit. So we see now that this supplier we would like to reduce. To reduce this, we have to shift the demands to these other suppliers. So this one supplier can be shifted to 3 other suppliers covering these items here. So these ones, and also there are other ones which cannot be shifted in the sense of this probability. But to go back to maybe also into a research direction, because this seems to be maybe also very practical for you, and also time is running. Just so what this is, so from a research perspective, it's the case, yeah. So my research is located in the area of self-service BI&A systems, so which really should empower business analysts to be more independent from more advanced analytical roles, and also be more independent from IT. And the current status quo before was that we have the data scientists who really consult the business analysts and also provide the analysis usually with Excel. But what if we can let them consume this machine learning model? So this is an example for an SBO task. What if you let consume without an consulting effort? So this meaning the data scientist solves an advanced problem with machine learning and puts the result to the model and make this model interactively explorable by business analysts, and setting up an SDNA system. And this is from a research perspective what I had showcased just with this SBO system. And there are definitely also other phases or other tasks. For example, if you imagine the CRISP cycle where we can deploy SDNA systems to business analysts to fill this kind of knowledge gap also. Okay, I guess time is already over. I'm now happy also to your questions, and we can dive also in a detail, maybe also in the model. I've prepared some slides for that if you want to. Sure, yeah.
Thank you, Sven. So questions from the audience? I have one question. So this is a tool for this is a self-service analytics system for supply-based optimization. So you have a domain, specific domain. Mm-hmm. And at the end, you said that your research is on self-service analytics system creating, but it is not related to any domain, right? Your research.
Right. It should be, domain independent, of course.
Domain independent. Yeah. So I would like to know what did you learn by creating this tool in terms of replicable characteristics in order to create self-service analytics systems, self-service BI. Huh?
So in a sense of maybe also design principles, and so what I learned also in a think aloud session is that at a first glance, for example, so we have here this model specific criterions, this probability threshold. This was at the first glance for business analysts difficult to judge. So what to put in here, they tend to put it to, or we need to be very certain, they tend to put it to 80% volume or something like that. And but it's really useful to let them explore also so the result of an algorithm and to judge it. So this is definitely something after explanation you can give to business analysts. And what we missed in this tool was that we really also needed to have kind of tooltips to really let them explain what's the probability threshold. So if they first use the tool without having any workshop before, then this is not self-explainable. So this is one. So the tooltip characteristics is one, but it was also interesting to see. So here are kind of 20 machine learning models behind it. We've pre-trained, and how such a tool can let them more or less easily kind of investigate and play around with the supply base. This was very cool to see, because the other option would be to just give them a huge Excel table. They will not explore in this detail. Yeah. So these are one things I've learned. Yeah, there are for sure others, but yeah.
Okay, thank you. So I think Miguel has a question.
Yeah. So this is interesting work. I I wonder if the bias that is behind this, that you want to minimize the number of suppliers that you are using, will not necessarily lead to something like supplier lock-in, something similar to vendor lock-in that you have that is problematic in many areas.
Yeah. So having less suppliers, so this tendency to have less suppliers, will lead to a vendor lock-in. Yeah. So this is kind of the gray side of supply-based optimization, I guess. Yeah. So, but it's, if you look at the costs, the administrative costs you have as an organization to manage very large supply bases, this makes then again sense at the end. So this is always a trade-off, I would say so. Yeah. So does this answer your question? Or?
Yes.
Okay.
Thank you.